Welcome to Embedded. I'm Alicia White, here with Christopher White. A few weeks ago, we mentioned a party to celebrate the 300th episode. How did that happen? It will be the afternoon of September 7th in Aptos, California. That's a Saturday, September 7th. There will be more details coming up. Most of it will be through the show, so don't expect to necessarily hear about it if you're just reading the show notes. In that same show where we announced the party, we had a listener email that asked about PICs, and I thought we gave a perfectly balanced answer. But then on Twitter, we got a message. Hey, at Embedded FM. I know you're fond of hating on PICs. I've used them forever and would be happy to come on the show sometime to defend their corner.
See, I think that's inaccurate. I think we're fond of kind of genially disliking on PICs, not hating so much.
I guess I should have made him read his tweet because our guest this week is Mike Harrison of Mike's Electric Stuff. It's a good excuse to chat with somebody I wanted to chat with anyway.
Hi, Mike. Thanks for joining us.
Hi.
Could you tell us about yourself?
I'm a self-taught electronics engineer. I've always liked taking things apart, and at some point I thought it might be interesting to do a YouTube channel recording me doing what I'd probably be doing anyway, taking things apart. My day job has started off as sort of like microcontroller consultancy, and I've sort of drifted into a weird little niche of lighting architecture, lighting design. We basically LED, usually things involving ludicrous numbers of LEDs. Incidentally, there may be some controversy. I tend to say LED rather than LED. It may cause some confusion, but it saves time. That's my argument, and I'm sticking to it.
Okay. So we want to do lightning round. And while you gave us lightning round questions, we're not going to use them.
Fine.
Worst thing you've ever torn down?
Worst in what respect?
Just the most depressing assembly or electronics job.
I mean, can I swivel that around to most dangerous thing?
Sure.
It was a small fuel cell in a completely ridiculous product, which basically was a fuel cell that cost way more than a similar sized USB battery pack. But when you open it, contained this very finely ground metal, which basically bursts into flames as soon as it reaches air. That was an interesting surprise.
All right.
What is your favorite flux for putting things together?
My favourite flux, I've got it here. It's actually, this is Future 315. It's like a very liquidy, it's like water liquidy type thing that I use to refill flux pens.
Is having one of your lighting installations lifted by a helicopter the best thing ever?
It's up there, definitely. Definitely. We figured out the original plan was to attach lights to the helicopter, but that involved all sorts of approvals and things. But if we just sling it underneath, it just counts as cargo. So there's very little paperwork to do.
NeoPixel, plain LED, or some other?
Never ever a NeoPixel. They're just not reliable enough for use in big permanent installations. They don't like being soldered. They don't have enough grayscales. They're inefficient. They're fairly horrible.
What is a tip you think everyone should know?
When you're designing a board layout, placement is everything. Spend more time on placement, and then the routing just does itself.
Okay. Do you want to continue, Christopher? No.
Whatever
okay.
you want.
I actually want to ask Mike the questions he wanted to be asked.
Okay, let's do that.
But then I'm going to ask why, because it's not lightning round anymore. What's your favorite LED driver IC?
Texas Instruments TLC5971.
Why?
Because basically it's a 12-channel driver with a SPI-like interface, which has 12-bit PWM on the outputs, plus an additional 7 bits of current control. So it means you can get super smooth grayscales. You can stack literally hundreds of them in a chain. and they're just, they work really nicely. They're easy to use, they're easy to drive, and they could be a bit cheaper, but apart from that, I use them a lot. I've used thousands of them, often in applications where if I could buy a reliable NeoPixel type device from someone like TI or Osram, I would use them, but we just can't really do that for various reasons. So I've built far many boards than I wished I had, with literally just loads of those TLC5971s with either RGB or RGBW LEDs on the other side of the PCB.
And you said SPI requires one line to go out to everything, but then you said thousands. So is it more like a daisy chain? Yeah,
it's a daisy chain. It's similar to the APA 102 type LEDs, where you've got clock and data going in and then coming out again, and the chip takes all the channels it wants and then forwards the rest down the chain.
Cool. That was the chip I was trying to remember.
Yeah.
So favorite LED color? I assume it's black.
No.
That's the easiest color.
Yeah, I have created the occasional dark emitting diode in my time, but no, white, for a number of reasons. One is it's very, very efficient. You get a lot of light for very little current. There's also, it loses any temptation to do horrible disco mode colors. They're also extremely cheap. You can buy Osram brand name white LEDs for the US equivalent would be about 2 cents if you buy them by the reel. So they're good quality LEDs and they're just very, very cheap. And there's one particular one, the Duris E3, which I haven't actually counted, but I must be getting close to have designed in 1 million in various installations. One installation alone, the Heathrow Airport one, that was 350,000.
That's a lot of soldering. Sorry.
Yeah, somebody else does that. I do have my own pick and place machine for smaller jobs, but anything that scale gets subcontracted.
What color of white?
Oh boy! Wow.
About, I would say, generally about 4,000 to 5,000 K.
That's pretty cool, right? Yeah.
It's like not bluey cool, but on the cooler edge of, warm. But although sometimes it's sometimes the case where projects happen on a time scale such that we're limited on color choice based on what people actually have in stock.
That seems fair. That is often how I choose color temperature for our home light bulbs.
No, you don't.
Well, yes, that's why I'm not allowed to anymore. What's your favorite voltage?
24.
That's a lot higher than I would have expected.
Well, no, for large scale stuff, you need a reasonably high voltage to avoid voltage drops. 24 is quite a nice compromise. There's gazillions of 24 volt power supplies out there because it's very common in the industry. Obviously, you can go higher, but as soon as you get higher, things like circuit protection become a little more tricky, because obviously you've got like one big power supply that's often being divided down into like smaller units and smaller fixtures. So you want to run thin cables, so you have to have fusing to protect those cables. I typically use sort of polyfuses, and once you get much over 24 volts, then those devices get thinner on the ground, or you have to go to through hole. And I've occasionally done stuff at 48 volts, but the thing you have to bear in mind that a large 48 volt power supply is not much different from an arc welder. 48 volts likes arcing a lot more than 24 volts.
Yeah.
All right. Yes, I can understand that. Okay, now PICs. We might as well just get this over with. Did we really slag on PICs that much? I seem to recall we said something like, electrical engineers like them, and we don't.
We were meanish.
Yeah, I think it's been a bit of a recurring theme. It's not just like the last episode. That's I seem to remember it's come up on multiple occasions.
Yeah, and the last one I think was like the nicest we've ever been.
Yeah, even we're getting tired of hearing ourselves.
Okay, so being an electrical engineer, you completely confirmed our biases because we said EEs like them. But, okay, yeah, why? Why are they better than other microcontrollers?
Well, obviously, there's no such thing as the best micro. Everything is...
They're all terrible.
With anything engineering, it's more or less applicable. But, often there's a focus on, it's a weird architecture and the instruction set's weird. But, I mean, the core CPU just almost never matters. You're writing stuff in C. It doesn't matter if that gets compiled to PIC code or MIPS code or ARM code in most of the time. It's all about peripherals, and it's also all about things which are nothing to do with the architecture. For example, most of the PICs I tend to use are the very low end, things like the 6-pin SOT23s, the 14-pin PIC8s, and then the mid-range 32s. But across nearly all their range, almost every device, you can get that same device in DIP, SO, SSO, and QFN packages. So you've got a huge range of choice. The other thing, which is maybe less relevant now that they bought Atmel as well, is that with their programming service, you can get them to pre-program the chips for you very, very cheaply. For example, in a SOT23 device, it's something like 4 or 5 cents per device for them to program it and put a coloured ink dot on it. So if you're doing something, I've done installations that have had thousands of very low-end PICs in them. It means that we can just get them already programmed, even if that's only got a bootloader in it and you put your firmware in later. Imagine even if you're on board programming, 1,000 devices take a lot of time. So that's a really major thing. And also, historically, you've always been able to buy them. Microchip have always been very good at almost never obsoleting, but also keeping stuff in stock. It's very rare that you can't get a particular device, and even if you can't, there's a good chance there's a pin compatible next one up in the series that you can. So a lot of it's about those, not really about the technical aspects of the device. It's about the logistics of using them, getting them. The other thing is, I tend to use sort of PICs at the two opposite ends of the scale. And the nice thing is that from a 6-pin SOT23 up to like a 144-pin 32-bit device, you use the same programmer, the same development environment. A lot of the peripherals are either identical or very similar. So, in a lot of cases, the best micro for a job is the one that you know. So, it means that you've got access to a very wide range of capability and prices without having to do much. You don't have to relearn the dev tools. You don't have to relearn the peripherals. So a lot of it's nothing really to do with certainly the core architecture. It's the actual practicalities of using the part.
And that makes a lot of sense, especially when you're using really tiny ones. And they're basically PLCs to some extent. They're being pre-programmed. You're using them to do something pretty small, and you want a lot of them.
Yeah, and I think that's where I think we talk past each other sometimes, because most of the things we're doing are pretty processor intensive. And so the architecture does become very important. Like, I do need a floating point unit that is reasonably fast for a particular application. So I'm not using 8 bits for anything very often. So that kind of eliminates a whole class of things.
And as software engineers, we don't care about logistics. Well, that's somebody else's problem.
Somebody else probably should.
Yeah.
Just to give an example of a typical large-scale lighting installation, what that might look like, it could be, let's say you've got a few hundred fancy-looking pendant fixtures with maybe 20 or 30 LEDs in them. What you would typically have is that fixture would have maybe a 14-pin or a 8-pin PIC, which is taking, let's say, a 50K board TTL level UART signal, and either using the PIC's own PWM to control the LEDs, or driving, let's say, the Texas 5971 drivers. That is then fed from a little box that's got probably a mid-range 32-bit PIC, which is taking maybe a 4 megabit RS485 signal, and then splitting that out to maybe 12 or 16 of those 50K board UART signals, one to each fixture. So you've got 12 connectors on this board that provides data to one fixture and fused protected power to that fixture. And the code in both of those is, I very rarely write anything that's more than a few K of code,
right? If
that. It's just basically doing a small amount of stuff to a lot of data at varying speed, from fairly quickly to really slowly, depending on the application. So it's very different from the thing with the huge user interface and Internet of Things and connectivity, whatever. So, it's important to remember that if you're working microcontrollers, you sometimes end up focusing on the sort of things that you do, whereas there's a whole world of other applications. So it seems, pretty much whenever I've heard you guys talking about it, it's always been in the context of, big applications that take months and months to develop. A lot of the time, the code will quite often just take a couple of days and that's it, finished, including a bootloader, so that I can upload the firmware for both that splitter and the fixture over the wire. Because it's very, very low. I don't like writing software. I much prefer building hardware. So the less software I have to write, the better.
Yeah, and I think that point is a lot of people complain about MPLAB and the tools, especially since they're not free. There's certain limits of size and the things. But if you're working on tiny projects and you're doing focused applications, but very application specific things with them, then that doesn't really matter either, right? I mean, if it's going to fit, it's going to fit.
People, I think, make a bit too much out of the non-free thing. In practice, the 32-bit ones, the free tools work absolutely fine. No problem at all. There's not a huge difference. When you get down to the 8-bit ones, the non-free, the free tools aren't very good at code optimization. But and we're only talking about the C compiler here. We're not talking about MPLAB. MPLAB's free. It's just the actual C compiler that we're talking about. And the nice thing about it is that MPLAB, you just install it, run it, and it works. So when I did the conference badge for the Hackaday SuperCon a couple of years ago, that was a nice thing that I could just give someone the MPLAB project. They just install MPLAB, load the project, press a button, and they're uploading code straight away. It's easy. It just works. Okay, sometimes it's a bit slow on some machines, but generally, everything's in one place. You don't have to find one IDE from somewhere else and a compiler from somewhere else and mess about with linkers. And the other nice thing, the way they handle devices is really simple. And literally, all you do is you hash include pic.h, and that's it. That's all you need to do in your source code. It handles the default linker settings and everything for you. It just happens. So if you want to just get a simple job done quickly, it just saves a ton of time.
And that makes sense. If you become very good with one thing, like PIC is controlled by microchip from the silicon through the C compiler. And so they don't have to do like GCC where they are trying to compile for everything in the world, and they don't have to, as you mentioned, linkers. They aren't trying to work with different linkers or different machine codes. It's all PIC and it's all controlled. And that gives you a lot of ease of use, but it makes it harder to change to other tools.
Yeah, if you want to change to other tools, obviously, yes. I mean, if you're doing something complicated enough that their environment isn't good for you, then you probably are a bit more limited. I mean, less so in the 32-bit. In fact, the 32-bit toolchain is based on GCC, and in fact, there are ways of overcoming the paid-for restrictions in a way which is probably not quite copyright infringement because of the GCC is a free tool. There are apparently ways of fairly simple ways of sort of tricking it into thinking it's the paid for version. There's a bit of controversy about how they've actually done that, which I don't think anyone's really interested in resolving strictly. But again, on the 32-bit compiler, I don't think there's anything I've done that really needs that last bit. I think it's mostly about code size rather than speed, but I've never had issues using the free version of the 32-bit compiler. I say the 8-bit's a slightly different matter, but the 32-bit, the free version is just fine.
I have the 32-bit, and I'm going to disagree with you, although perhaps I need to go find your workaround. And my problem isn't that it isn't fast enough. It's that I know if I optimized more, I could get to a lower power, which is one of the great things about PIC is that you can get to low power. But I need to optimize more than the free compiler because I know there's stuff there and I can't leave those microamps on the table.
Yeah. But that's presumably just how long you're awake sort of issue.
Yeah. Do you normally program in C or do you program in assembly?
When I started using the PIC back in when the original OTP 54 chips came out, I did a lot of assembly. It took quite a while for me. I've always had a very big distrust of big bits of software and so on. So it took me quite a while to sort of see the light that C was actually the way to do it.
I love that you think C is high level
compared to assembly. I mean, having said that, I often write C that I generally treat C as a glorified macro assembler.
Mm-hmm.
I'm always the sort of code that I like writing the most is the sort of code that you need an oscilloscope to debug and test. Squeezing, doing things like 12-bit bashed UARTs at 250K board in software. That sort of thing is the sort of thing that I like doing, and like doing really weird things with DMA controllers and that sort of thing. I've never got into. I can vaguely follow the 32-bit assembly, but I've never actually spent the time to look at the MIPS stuff. But certainly on the 8-bits, sometimes I will look at the assembler output the compiler's generated and tweak the source code to make it compile to the assembler that I think it should be assembling to for speed and so on.
Well, we're not arguing. I thought this show was going to be all about arguing with each other.
I still don't want to use them.
Fine.
But it's fine if everybody else does. That's cool.
Yeah. I mean, there are places to use them. I didn't realize they would pre-program them for you.
Yeah, that's a huge benefit.
There are times that...
and it's a very low minimum. It's either 150 parts or $150 and a trivial setup charge. Yeah. And it's quick. Yeah. I mean, if it's a stock part, it'll add maybe 2 or 3 days to the order from Microchip Direct. So it's actually a very major advantage in some applications, because although there are third-party programming services, they're generally a lot more expensive because they've got to take the part out, re-reel it and generally mess about. But also, I believe DigiKey offer a programming service, but they don't offer it outside the USA because they're scared that you might send them some code that's got export control degree encryption.
Yeah, my weapon's great 8-bit processor.
Yeah, exactly. Yes, it's ridiculous and it's annoying, but that's their attitude.
Yeah, well, that kind of service can make the difference between, hey, I can do a product on this and I can't. So that's pretty interesting.
And setting up a manufacturing line is just
it's
so hard
for a small run thing.
I mean, just on the production side, another neat thing. I'm sure there probably are other tools that do it, but again, this is nicely integrated into MPLAB. On the Picket 3 programmer, it's got this facility called Programmer to Go, which means you can load your code into the programmer, and it then becomes a standalone program. You just literally give it power, press a button, it'll program your part, and then show a red or a green LED when it works. So that if I'm doing a small production run, I'll just program one of those programmers up and send it to my subcontractor, and then that becomes part of the production programming and test procedure, which again, it saves a hell of a lot of time. Especially, almost all of my jobs are one-off, so we don't have time to optimize a test procedure. It's a case of, okay, here's the job, build it, test it this way, and send me the boards. So to be able to just send them a program and say, push this programmer with a pogo probes down, press the button and wait for the LED to go green. Yeah, that just saves a huge amount of time for setting jobs up.
And the programmers are cheap enough that you can... Yeah. They're so much cheaper than trying to do this with a Cortex M something where you need a JTAG programmer and a laptop.
Or some, multi-gang system with 8 UARTs and... I've done all of those things. Yeah. I will say I'm a huge hypocrite because the first microcontroller I ever used was a basic stamp. So
well,
which I loved. So.
I mean, the one thing I think Microchip did is they really got people through to the idea of using, like at that time, one-time programmable parts in production. Because before that, you had things like 8051s with external EPROMs. You had very expensive chip packages with an EPROM actually plugged into the back at the top of the package itself to emulate parts that were going to be burned into mask-ROM in future. And Microchip were really very much the pioneers of low-volume, single-chip micros.
And now they've eaten Atmel, which was the other one that was good for small micros.
Yeah, but Microchip were before Atmel in that respect, certainly.
Yeah, definitely.
Yeah. Okay, so it sounds like we're mostly in agreement on all of this, much to my shock and horror. Yeah. Tell me about your lights.
Okay, well, I think probably about 12 years ago, I sort of fell into this rather interesting and weird world of... Basically, when people ask me, I tend to sort of suggest the Venn diagram of, if you draw a Venn diagram of artists, architects, and lighting designers, most of my customers fit somewhere in that area, but generally not completely inside one of them. And what I've sort of found, the niche that I've fallen into, is when people want to do something like a large-scale lighting installation or an art installation, and they can't do it with off-the-shelf electronics, they call me. And it's one of those areas that everyone's, pretty much everyone in the area knows everyone else. For example, one of the customers I worked for originally, loads of people who left that company started up their own practice or gone to work to other people. So it's all like word of mouth. And I now routinely get like second and third hand referral, like someone will email me and say, hey, XYZ person recommended you, and I have no idea who that XYZ person is because it's been a second or third hand sort of referral.
Working with artists seems challenging, both because they tend not to be paid and because their ideas may not be physically possible. Do you find either of those to be true?
Not to a huge extent, because most of the people that artisty type people I work with are already fairly well into the market. They understand. They're not people that have just got some random ideas. There's probably two of my clients that are fairly big into literally like hang on the wall art type things, and both of them have been at it long enough to have at least some sense of what's sensible, and they know enough to get me in early enough so that they don't present this amazing like structure and I say, okay, that's very pretty, but where are you going to put the wiring? Things like that. They tend to talk to me fairly early on so I can guide them into what's feasible, what's practical, cost and so on. So that's not, we're talking sort of mid to high end here, not just the struggling artist type people.
And so how much input do you get into the design beyond the technical limitations?
There's usually some. Again, it varies from client to client. There's some where I've literally designed and implemented all of the content side of things because I just hadn't got around to doing it by the time this thing had to be installed and working. Other cases, they've got a very firm idea of what they want, but there's always a certain amount of negotiation in terms of, okay, that's very nice, but if you do it this way, it's going to cost you half as much. This sort of thing, like, they say, okay, right, we want 20,000 LEDs and we want every single one of them addressable separately. And I said, well, actually, do you? If you can maybe say, let's say, have 3 LEDs per pixel, it's going to slash your power, slash your cost, whatever. And they're often quite amenable to. I might say, okay, let's build one prototype that's fully addressable, and then play around with your content to see how many pixels you actually need. So that I'm actually doing something exactly like that at the moment. It's actually for a lighting rather than an art type thing, but they know they want some sort of movement within the light fixture, but they don't really know what resolution. So we've made some, fairly impractical for production demo strips that they can then play around with to test the visual effect of different resolutions on.
What kind of visual effects are we talking about? Organic things or...
Anything pretty much. It's either organic things or it's things. For example, the Heathrow Terminal 2 installation is over a seafood concession, so it's meant to represent like shoals of fish swimming around in a sort of fairly abstract way. Sometimes it's just pure aesthetic. Sometimes it's almost playback of video, low res video content over maybe a slightly unusual type display, but displaying what is basically video that they generally. The meeting point between what I do and what my customers do tends to be the USB port. So they generate all the content, they write software to do all the graphic stuff, and then they just throw pixels at me and I display them. That's the most common sort of scenario.
So there isn't much interaction?
There can be. I mean, the problem with interaction is... it either has to, and this is sort of become almost sort of Mike's Law in interactive lighting installations, in that unless it is really immediate and obvious, like you move, wave your arm and something immediately happens, it might just as well be random. Because you see so many installations where, the colour of this thing depends on the tide in this country or whatever. And it just, most people just don't get it. Whereas if they can literally, the thing that people engage with most when I sort of actually see people engaging with things is if they can stand on there and wave their arms and this thing does something cool, they love it. And it's very obviously interacting. But there's a lot of times when, as soon as you break that immediacy, it's unless you either get it explained to you or see it on a time lapse, it's, it might just as well be random.
LEDs have changed so much over your career. We already mentioned neopixels. And things have gotten smaller. Blue is now a viable color. What have been the most interesting changes to you?
I mean, there's obvious things like the fact that white LEDs are so efficient and so cheap, which means that, you can use zillions of them. And certainly the cost of placing them on the board is more than the cost of the device itself. That's probably one of the biggest things. And I tend to prefer doing stuff in like single colors, because as soon as you go multicolor, it's very you very risk tipping over into horrible disco. Like when desktop publishing first came out and people used every single font they could just because it was there. it's the same sort of thing. I mean, certainly I'll tend to, if somebody wants RGB, I say, well, no, you probably actually want RGBW, because the white will give you the light, the power you want at very, very little, the optical brightness that you need, but also it gives you a lot of subtlety in that you can produce nice pastel shades and subtle colors. Whereas if you have RGB and you want to do white, it always looks horrible. If you've ever seen an RGB display trying to look white, it looks terrible because it's never quite balanced. You've got 3 separate colors where each LED has slightly different intensity and color. It's you're never ever going to make that show a nice white. Whereas with white LEDs, it not only appears white and uniform, it also takes maybe about a tenth of the power.
Okay, RGBW. I'm frantically Wikipediaing so that I know the difference. I assume it's not the Royal Gloucestershire, Berkshire, and Wiltshire Regiment.
It's red, green, blue, and white.
That's what Wikipedia told me to.
There was
I know. I needed the disambiguation page. So RGB makes sense. I've used those a bunch, and the white comes in
because mixing RGB to make white isn't as good as just having a white LED.
But do you use the white other than the RGB? I mean, you mentioned pastels. Is that like in order to get a light red, you use white and red instead of?
Yeah.
Okay.
Whereas, for example, let's say if you want like a nice subtle pink, if you try to do that with RGB, all you're doing is you're fading the blue and green down very slightly. So you have, again, because most of what you're generating is white, that's never going to look very uniform. It's going to, it almost always looks really horrible. Whereas if you generate white and then just add a little bit of red to it, it looks, a lot more uniform, and it takes a lot less power.
This is very true. All the times I've played with RGB LEDs, I've had this problem, and I didn't even know. I didn't know there was a solution. Thank you. When did these come out?
Well, I mean, you've always been able to get an RGB LED and stick a white LED next to it. There aren't that many single parts that do all 4. There are some Chinese ones which are sort of okay. That's about the only. I don't think there's any low power RGBW LEDs from like mainstream manufacturers. There's quite a lot of the higher power ones, and by low power I mean like sub 50 milliamp, and the higher power ones are the sort you tend to need to stick on a heatsink. But what I almost always have to do is take an RGB LED from someone like Cree and stick an Osram white LED next to it on the PCB as close as I can get it.
Oh, okay. So you're making the RGBW as a unit.
Yeah.
Do you sell those?
No, I mean, not as such. No, I mean, basically what I tend to be designing is custom LED fixtures or control solutions. So, for example, a job I did about a few months ago, they wanted 1 meter diameter rings with RGBW on the inside and the outside. So these were like 2 PCBs, one inside, one outside. Each one was made out of 2 1 meter long strips, which had RGB and W LEDs alternately on one side and drivers on the other side. So that was just a custom job where, for larger jobs like that, I'll just charge a fee for the design work and the prototyping, and then just give them all the information they need to give to a subcontractor to actually manufacture.
Oh, I thought you had a store where you could buy stuff.
There are 1 or 2 things which I've designed which are now sort of occasional products. Those are basically high channel count dimmers for running RGB or single color LED strip, the 12 and 24 volt LED strip. So these are 48 and 96 channel. Basically, they're just PWM outputs to drive constant voltage LED strips. And those have been used in quite a few installations. Again, if you want a large number of, particularly strips, occasionally sort of, higher power clusters and so on, but it's generally strips. And in fact, the reason the 48, I think the 48 channel came about, there was an installation we were doing at about 5 years ago at Heathrow Airport, where we had some large butterflies which had RGB LED tape around the edges so that you could light them up, and they had like etched patterns in them. And there were quite a lot of these. So I think we used, I can't remember the numbers. It was something like 8 48 channel dimmers. So each 48 channel dimmer would run 12 RGB strips at 24 volts. And then the 96 channel, that was actually a company that makes very large architectural models that they want to light up. So, like huge building developments on like a model the size of a table. And again, they had all the lighting they wanted to control. And if you want to control, 96 separate either LEDs or strips of LEDs, it gets really messy doing it with like 4 or 8 channel off-the-shelf controllers.
So that leads me to a question. Some of your installations and things have been, like you said, somebody comes to you and says, I want 20,000 independently addressable LEDs.
Yeah.
What is the architecture when you finally arrive at something where, okay, it is a large number beyond 96 in the thousands or hundreds? What does the architecture of your system actually look like to distribute that? It varies,
but, it does vary, but a very common feature is there is a custom fixture which takes 24 volts and a TTL level data signal, and that will have, let's say, for example, it's maybe like a 1 meter long board that's got LEDs on both sides that sits in an acrylic tube, for example, for like a hanging pendant type fixture. There's another one I'm doing at the moment where each node is like, I think it's about a 2-inch diameter board with about 12 RGBW LEDs on it, and that's going to have like an acrylic diffuser on it. So basically it's a semi-intelligent fixture that takes typically 24 volts and a signal line data signal, and then that plugs into a board which takes either Ethernet UDP or RS485 at fairly high speed, and then splits that out into lots of channels at low speed. So in terms of addressing, this splitter unit has a dip switch on it that says which device it is on the RS485 bus, and then which socket you plug your fixture into determines the sub address within that. And you might have some number of these boxes from like a few to like 20 or 30 on maybe perhaps multiple RS485 buses. I mean, I've had installations that have used a 16-port RS485 to USB converter, throwing data out at, I think, 4 megabaud on every single port for most of the time. But my general philosophy is keep it as simple as possible. So RS485 is easy because you can just stick it on a scope and debug it and do the protocol decodes. It's super easy to decode, but also by splitting it into a modular system, you have the fixture, which is basically independent. So if that fixture works, 1,000 fixtures are going to work. You have that splitter unit, which again, if that can drive 20 splitters, you can then just multiply those up to however many you need. You just need to keep a handle on overall system bandwidth, but also power, because obviously power is one of the biggest issues. You've got one of these splitters might typically have a 24 volt, maybe 20 amp power supply connected to it, and each output might have polyfused at perhaps 1.5 amps, something like that. And then within the fixture, it would either have, for example, a bunch of, let's say, 6 LEDs in series per pixel running directly off that 24 volt supply, or it might have a DC to DC converter in the fixture to convert it down to, say, 5 volts if you need to run the LEDs individually, so that you end up with a nice thin cable to the fixture, and you don't care about voltage drop because that DC to DC converter will deal with that voltage drop along your nice thin, pretty white decorative cable.
You make it sound like this might be a little harder than just slapping some LEDs on a controller.
It's easy once you know all the snags, and things like power, voltage drop across the cables, moving your ground level, and getting to really, really know your USB to RS485 converter to figure out how big a packet you can send before the thing stalls. So if you're sending data out to 16 RS485 ports simultaneously, it's absolutely essential to get the packet size right, because it can make a factor of like 30 or 40 difference to your overall throughput.
Now that's a software problem.
Yeah. But I need to tell the software guys about it, because most software guys, things like throwing data to an RS485 interface via USB, it's often right at the edge of their capabilities because they're software guys. So they tend to have to be handheld to some extent to explain, okay, this is exactly what you need to do. Your packet needs to look like this. You need to split the packets up. You need to send like 1K to this port, then to that port, then to that port before you send any more to the first port and all this sort of stuff. So I have some standard documents that I tend to send to people. If it's like a new custom with a new programmer, I sort of send it to them and say, read this, understand this. I'll quite happily talk to you if you don't understand it. And there's one, I mean, a lot of the programmers working in this area, they're into like the graphics and the 3D stuff and all that. And there was one occasion with a programmer who I shall not name, who when I sort of sent them documentation showing, for example, they need to send this packet and this bit controls this and that bit controls that, he asked me to explain how binary worked.
Ouch. Ouch. Yeah. Don't start from there. One of the things I want to go back to was dimmers, which was, you mentioned the 96 channel dimmers. And I got a little caught up for a second there because looking around my house and LED lights, some of these lights are very bad at dimming. Why are some LEDs so bad at dimming?
Because your LED light bulb has a driver inside it that takes your AC mains voltage and produces constant current from the LED. Traditional light dimmers that drive tungsten lamps, will mash the waveform up to give the tungsten filament the amount of power it wants, which works fine for tungsten. But when you feed that into a switch mode power supply, it usually doesn't end well. There are drivers that are designed for dimming. You'll often find, if you look at even just domestic LED house bulbs, they'll say dimmable or non-dimmable, and that's about the architecture of the internal driver. And even the dimmable ones have some limits. They won't generally dim all the way down to zero. They'll have a minimum of like 20% or 30%, below which it gets really flickery. And you can now buy like wall dimmers that you can set a lower limit on to keep it out of that range.
Okay, going back to what has changed over your career, was there anything that you were like, yeah, that's never going to work. We're never going to get that we did something or something where you were like, oh, in a year we'll be able to have hover cars?
Not really. I mean, most of what I do is pretty low level, really. It's controlling LEDs. There's a scale aspect, but that's about just divide and conquer. It's really just the reduction in cost of LEDs themselves, but also there are some things that I do which are things other than LEDs. I've done a few installations using large liquid crystal displays, like say for example a 3x3 inch single pixel liquid crystal display that goes either transparent or not transparent. And the nice thing about that is the power consumption is very, very low. So you can have like huge arrays of those. There's actually one we did quite a few years ago in a shopping centre in London that was, I think it must have been about 50 feet high with like huge panels on each side with these reflective LCDs, which looked great. And the whole thing was powered at 12 volts down a Cat5 cable because these things just used no power because they weren't emitting light. One thing that I would really like to do at some point is a large-scale e-ink, e-paper type installation. Again, for the same reason, you can get large-scale stuff happening without having to have ridiculous power cables all over the place.
Well, you need a higher voltage for those, but you don't need to power them at all sometimes.
Yeah, exactly. The fact you can get large area. I think at the Electronica show last year, I did see one company making very low resolution e-paper displays for architectural applications. So I sent information to a few of my customers that got quite excited about that. Nothing's come of that yet, but I think it probably will at some point because obviously everyone's looking for something that's different and new that other people haven't done. I'm surprised that I'm not aware of any large-scale e-ink stuff that's been done yet. And it's obviously when e-ink first came out, you could only buy them if you were making Kindles, but obviously now it's easier to buy lower volume stuff. But most of the e-ink products are still aimed at like text and graphics display, whereas what I want is like something that's maybe A4 size with perhaps 16 pixels, something like that.
Yeah. You could have a building that some days it was black, some days it was white, depending on what the building wanted.
I want a display that you can only make out from space.
That was actually a brief on a project I talked about a while ago, but it didn't happen.
300 DPI, but you have to be 200 miles up.
Yeah.
Okay, so it sounds like we can talk a lot more about lights and e-ink, all of these things, but there is something else you do. You have a YouTube channel where you take things apart and you explain things together. Yeah, you put things together, and then occasionally you have a little minor rant. Why do you do this?
Well, I mean, there's really, I suppose there's two strands on the YouTube thing. One is just the teardowns. It's taking stuff apart. As a kid, from when I was a kid, I've been into electronics since I was about 5. I've always loved taking stuff apart. I got quite good at putting it back together again at a fairly early age. But I'm always, I can hardly ever buy any bit of equipment without taking the lid off to see what's inside it. And that side of the YouTube, it's basically making content for people like me who are too scared to take the lid off things, or who don't happen to be able to get hold of an X-ray machine or a pill camera or some other weird bit of lab equipment, like a DNA analyzer that you can buy on eBay for not that much money. So that was very much, doing stuff that I'd probably be doing anyway, but also, exposing it to a bigger audience. The other side is I do like electronics, not so much tutorials, but one of the nice things about what I do for a job now is that all my customers care about is this thing is there and working. So it's like design it, build it, and they don't want to hold any of the IP or anything like that. So I can talk about the detailed aspects of the design of these things, and I've done quite a number of videos on that, and those have proved very popular. Just explaining why things are done the way they are, and going through the design sort of procedure. And I quite like doing videos like that, because I think it benefits quite a lot of people just seeing the design process from the inside. So, and there's just random other things like reviews. I get companies wanting to send me stuff for review quite a lot, most of which I turn down. The only stuff that I tend to take is stuff that I would use anyway, or if it's just something that's such a high price tag that I just can't resist the offer of a freebie.
I totally understand. And I understand turning them down, because sometimes you're like, well, if you send that to me and I don't like it, am I going to have to say something? I will have spent time on it.
No, my standard, if I get a random key, the first thing I say back is, okay, yes, I'm interested in this. I'll have a look at it, but you won't have any right of review. I will say what I think. I will take it apart. And if they're happy with that, then fine. And most people are. I don't think I've ever, really slagged anything. If it's something which I clearly think is a piece of rubbish, I won't even bother doing it. If there's something that's really ridiculous, that's not expensive, I might just buy and just do it for the hell of it. I'd sooner do that than actually get it as a freebie. I'd sooner just have the independence, just buy it and just rip the crap out of it. That hasn't happened very often. So I just don't have time. Because the YouTube thing is very much a hobby thing. I don't do it for the money. It took ages for me to get around to doing any sort of monetization or Patreon type things, and the only time I do that is if I have to buy something to do a teardown, or if I have to rent a van to take a bit of kit somewhere. So it just means it basically doing that has increased the threshold of shall I buy this just for the hell of it on eBay, some bit of weird kit that I don't quite know what it is. So things like DNA analyzers and that sort of thing.
And you brought up DNA analyzers, which was my next question. When you do teardowns, you don't do teardowns of things people expect, like the fluke DMM that's sitting on your desk. You did a teardown of a DNA system.
Several. Yeah. Weren't there
several?
I
mean, my absolute favorite thing is bits of equipment which were originally ridiculously expensive and now almost completely obsolete. And DNA analysis is one of those fields that's moved so quickly that literally, the first one that I did, I paid, I think, something like £200 for, and the brand new price of that was like $500,000 or something ridiculous. And it had like a camera inside that was like $150,000. It had this massive, great CCD sensor, but they've actually, you can't even buy the chemistry to use it. So it's like having an expensive printer they don't make the cartridges for anymore. And even if they did, the cartridges would be so expensive that you could just go buy a cheaper printer that performs better, because that field has moved forward so quickly. But the nice thing about that sort of thing is it's a niche industrial thing that was just built almost regardless of cost. So you get very nice, beautiful mechanics inside it, amazing optics, I
totally, DNA, yes, I totally understand this. I went to HP's bioscience division in like 1998, and we did one of the first DNA scanners, big DNA scanners, and it was definitely $500,000. And now I'm working with a little company that's making one that's kind of field oriented. Like you take it out into the field, and it's
just an app.
It's like
just point your camera at somebody. Yeah,
it's in the kilobuck range, not in the millibuck range. And it's just amazing how much that technology has.
Well, a lot of the cost of those things goes into the custom. I mean, it's not necessarily the parts, although the CCD cameras usually are pretty pricey, and the motors and stuff. But I mean, I was thinking of that I wanted Mike to someday get a hold of the medical laser I worked on years ago and tear it apart and see what he thinks. But a lot of the expense of that was just the optics. I mean, we had this gold-coated scanning wheel that cost, not that much to make, but the NRE was millions and millions and millions and millions of dollars. So yeah, a lot of the cost is in the okay, how do we get this all arranged? Not in what
and
parts
of course,
of
design and development. A lot of these things are built in fairly small quantities, so there's a huge amount of development cost.
Well, with the Agilent ones, it was like they were all lovingly hand built.
Yes.
Do you have any other favorite teardowns?
Not. I'd probably have to look through the list and remind because I've just done so many, and I've not done that many for a while. But again, it's the thing that I have no clue what's inside. I know there's going to be something interesting inside, but I don't really know what. That's my favourite thing. It's like that discovery and the surprise of thinking, oh, there's what's all this mechanical stuff, or just or say like in that fuel cell thing. Oh, look, it's catching fire as I'm taking it apart.
Oh, look, it's catching fire.
Well, these are fun to watch, but you also, I mean, some of them have some interesting info. Like you did the comparison of the electric car chargers, which I thought was really cool.
Yeah,
because it was like, is it really worth it to spend a little extra for one that's not from random company? But the thing that was terrifying to me seeing that teardown is I didn't realize they carried the full load on traces on the PCB. It just makes me really nervous for some reason. Not being an expert EE or anything, but it's like 32 amps across a couple of traces.
Well, I mean, that also just goes back to, for example, that 48-channel LED dimmer. I mean, that is normally rated as a 1 amp per channel. So, you can have 48 amps going through that terminal. So that's like a 2-ounce PCB with tracks on both sides, but with very, very careful layout design that you're not moving it very far. Yeah. And I think on the 96 channel, I do actually solder some wire across to distribute the power, just to reduce the heating a little bit. But large amount of currents do get quite fun to push across PCBs. But again, in the case of those chargers, you could see the way they designed it. They designed it to minimise the length that current was going across the PCB. They'd done it on both sides, and pointing a thermal camera at it, it was clearly okay because it wasn't getting particularly warm. So, once you get into tens of amps, interesting things that can start happening.
Do you have any videos that you worked hard on, or that you were especially pleased with that people didn't seem to notice?
Again, it's hard to remember. I tend to get fairly consistent view counts. Obviously, most of it's from subscribers. I don't think many people sort of randomly stumble across it. I think things like, for example, the car charger one, that got quite a lot more because obviously there were people looking from the electric vehicle type forums that I posted it on. But I don't tend to spend too much time thinking, okay, and was it worth doing that amount of work? I mean, as you can see from my production values, I don't spend a huge amount of time on that. It's generally like shoot it in the afternoon, edit it in the evening, and it's on YouTube that night. Partly because, if I don't do it, then I'll be busy with something else. It will never get done. But also, I sort of shoot everything in sequence, so I don't have to remember everything between shooting and editing. So it's very much just get it out there as easily as possible. I get numerous complaints about that, but this is just something I do for fun. Yeah. And it's either interesting to you or not. Whether it's superbly sort of polished or not, it ought not to matter to most of the people that are actually interested in it. So,
yeah, well, it's this or nothing, kids.
Yeah, exactly, absolutely, that's exactly it.
Well, Christopher, do you have any other questions?
At what point did you realize you could make a career out of this?
Well,
was it fast, or was it like?
No, I mean,
a couple
it
years?
happened. many years previously, I basically was starting to tinker around with PICs anyway, and this was in the time before, for example, big companies like Farnell stocked them. You had to talk to specialist distributors. So I was talking to my local distributor from a company that I don't know if they even exist anymore, just to get some parts and some programmers, and just for playing around with them. I was doing I think I'd started doing some electronics consultancy there, and they just called me one day saying, "Oh, we've got this customer we're trying to sell PICs to. They're currently using mask-on parts, but we need someone to do the software. Do you want to sort of meet them and see if we can get something happening?" So I went along with him. They clearly had really bad experiences with a previous consultant who, because they were using these mask-on parts. They'd spent months and months, and this product was something literally, it was a fire alarm sounder, so it had to make like one of, I think, 10 different combinations of beeps and whoops and whatever. So it was a really simple thing, but this was in like a 1K memory, or no, 512-word memory PIC. So I said, yeah, it should be okay. I'll prototype it. I'll maybe come back in a week and show you it working. And the guy, his facial expression said that he clearly did not believe that this was possible. So a week later, we went in, it all worked, and I then did work for them, both hardware design and firmware, for many, many years. And then, for example, guys from that company left another company and they wanted some stuff done. So for most of what I was doing was just general electronics consultancy based around PICs, occasionally other things. And then I went to a presentation on I think you may have it in someplace in the US, Dorkbot, which is basically a presentation of people doing presentations on interesting things. That the tagline is "Doing Strange Things with Electricity," and one of the presentations was from a company that I subsequently went on to do a lot of work for, where they did it was like a conference table with lighting above it and RFID readers in the table, so that as they moved various bits of table furniture around, the lighting reacted. And it was very clear from that presentation that they were at the very limits of their technical abilities to get this thing working. So I just went up to the guy and started chatting to him and said, "Look, I think I can help you guys." And that was it. I'm still doing work for them today. That was probably at least sort of 12 or 13 years ago. And the nice thing about that sort of work is that it's a case of design it, build it, ship it, next job. You don't have all the really boring stuff like, the production engineering and all the, documentation, all that sort of stuff. I'm very much, the next new job is always more interesting than anything I'm working on at the moment. And the actual design and problem solving is the thing I love the most. So, I don't do any production stuff at all these days. I just can't maintain enough interest throughout that process to do it.
That's a great place to be.
Yes, definitely.
Sometimes.
On the other hand, you talked about the hub and spoke architectures and testing things and being able to test things modularly, which means that the production has a path, it has a plan. And when you're doing installed electronics and you've done outdoor installations, this is not a cushy environment.
No.
I think you did one that was near the ocean. And my response to that was like, "Oh my God, salt fog. It was so horrible."
I think I don't remember. I think you might be confusing it with something else. But generally, not much stuff is outdoors, and if it is, I just go over because the actual cost of the materials isn't a huge factor generally. Anything that's outdoors goes into a die-cast aluminium IP68 box, not a plastic one. It's got decent cable glands. It's got decent quality waterproof connectors, etc. So, generally, when I go into a customer, the first thing I do is I terrify them by explaining all the ways in which it could go wrong. And then when it doesn't, they then get a nice surprise. But it's generally, there's no point in cheaping out on things like connectors, using NeoPixels, whatever. Certainly on temporary installations are a bit different, but for a permanent installation, the cost of it's not worth saving a few pennies here on there, because that's nothing in the scheme of things. But the cost of it going wrong is much higher. Like, for example, if this power supply say, for example, don't put power supplies in the ceiling. So you need a cherry picker to go up and get them if they go wrong. The cost of going out somewhere, which may be in another country, to fix something, and because it's a one-off, you can't just call your local tech to go fix it because they haven't got a clue what it is. That's actually a fairly long-term, persistent problem. So you have to just do everything you can to make sure that A, things don't go wrong. B, if they do, then, for example, there's easily, you just say, okay, just swap this for your spare modules, always make plenty of spares. So if something goes wrong, they can just swap it out, and just try and think ahead of all the things that might feasibly go wrong and try and do your best to mitigate that.
Is there anything, as you continue to do this, do you keep on top of new developments and things? Is there anything you're looking forward to make your life easier or do nifty new things?
No, I mean, what I would like the most is for, let's say, somebody like Osram and TI to get together and do a LED with a built-in driver that I could trust.
An RGBW LED.
An RGBW, even if it costs like $1 each, I don't care, because that'll just save, the fact that I can design something in with confidence, that it's just going to work. Because a lot of the time at most we'll maybe do one prototype, but it's generally a case of we have one chance to get the production run right, and it's got to be right. So we don't have the time to like qualify parts over extended periods of time and do extended testings and burn-ins. There isn't time to do that.
You mentioned you went to electronics self-taught. Why didn't you go the uni route?
I did start university. I've always been terrible at maths because the way it was taught, that they would teach you calculus, explain it, but without explaining you why you might want to know the area under a graph. So I didn't really pay much attention. So I did I started the computing with electronics type course and dropped out after the second year because I'm very lazy when it comes to academic things, but B, I just didn't really. So again, some of the computing side was a bit too abstract for sort of my liking. I've always been a practical, hands-on person. So if I want to learn something, I'll just tear into it and play with it and, figure it out myself. And pretty much everything I know I've learned by, building things, taking stuff apart, and all the other sort of cool stuff. And obviously, this was before the internet was a big thing. So I used to have like a massive wall full of data books. Right. But I've always been the sort of person that I learn by just doing things.
It's impressive to me. I learn from books, and when I do things, often I just get frustrated and lost. So I'm always interested that people learn in different ways.
Yeah. Just quickly going back to the PICs, one other just minor thing on why I use 8-bit PICs at all is things like supply voltage. You can run like anything between, say, 2 and 5 volts on the device. So, and also they've got like 1% on-chip RC oscillator. So, for example, my LED fixture that takes UART data in and spits like data out to the drivers, literally it's just the PIC, a couple of resistors and the decoupling cap. The 5-volt supply goes straight to the PIC. There's no crystals or anything. So it just keeps things nice and simple.
I think one of our listeners mentioned
one
of our listeners mentioned the power friendliness was a big feature.
Yeah, and they're fairly robust. All you need is a series resistor to protect it against a short from the data lines of 24 volts, for example.
Didn't I say in that show electrical engineers like them because they require fewer parts?
Uh-huh.
Yeah, that's always a good thing.
You're fine.
I'm just making sure. Well, Mike, thank you for being with us. Do you have any thoughts you'd like to leave us with?
Never try to catch a falling soldering iron.
That is great advice.
I have a couple burns on my hands from last weekend, but they were from the desoldering.
And you can never have too many test points.
Oh, yes. Please, all electrical engineers, listen to that one really well. Our guest has been Mike Harrison of Mike's Electric Stuff YouTube channel. He's also the founder of White Wing Logic, an electronics consultancy in Essex in the United Kingdom.
Thanks, Mike.
Thank you. You're welcome. It's been fun.
And I would like to remind you that we are having a party for the 300th episode. It will be Saturday, September 7th in the afternoon in Aptos, California. You can mark your calendar now, and we will release the details and RSVP information around August 1st. Thank you to Christopher for producing and co-hosting. And of course, thank you for listening. Thank you to our Patreon supporters for Mike's Mike. And you can always contact us at show@embedded.fm or hit that contact link on embedded.fm. And now a quote to leave you with. Let's see how far I get on this one. Peter Piper picked a peck of pickled peppers. A peck of pickled peppers Peter Piper picked. If Peter Piper picked a peck of pickled peppers, where's the peck of pickled peppers Peter Piper picked? Yay! Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.